For this module, we'll be learning how to graph the sine and cosine functions. So for the standard form of the equations of both sine and cosine, there are several different forms, but what we will be using for this module is y is equal to a sine of quantity b, open quantity x minus c, close quantity plus d, and then the same for cosine. In this, you can see some of the properties of the curve, wherein the absolute value of a is equal to the amplitude. That is actually the maximum y value minus the minimum y value all over 2. The quantity or the coefficient b determines the period of the curve, wherein the period is equal to 2 pi all over the absolute value of b. The constant c determines the phase shift, or what you call the horizontal movement, wherein if c is greater than 0, the curve moves c units to the right, whereas if c is less than 0, the curve moves c units to the left. D, the constant d, determines the vertical shift, wherein if d is positive, the curve moves d units up, and then if d is negative, the curve moves d units down. There's also the equation of what you call the midline, where y is equal to the d. Let's go to the basic sine wave. For the function y equals sine of x, the x values here represent the quadrantal angles 0, pi over 2, pi, 3 pi over 2, and 2 pi. The y values for this one are 0, 1, 0, negative 1, and 0. And for negative 2 pi, negative 3 pi over 2, negative pi, and negative pi over 2, the corresponding y values are 0, 1, 0, negative 1. So that is present in the graph at the bottom in here, wherein at 0, the value of y is 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's negative 1. And at 2 pi, it's 0. So you can see here one complete period for the pink graph. If you look at the graph on top, you can see in here, for example, for angles pi over 6, this would be the value of y at x at the angle pi over 6. Pi over 4, this would be the y value. Pi over 3, and this is at pi over 2. So this one would correspond to the heights of those graphs here. And so you can see in here that at 2 pi over 3, the value becomes lower. So that means from 1 in here, the amplitude, it would go down. So the x-intercepts or zeros can be solved at k, pi, where k is an integer. For sine, the domain is any real numbers and the range would be the amplitude. So from negative 1 up to positive 1. So you can see in here that sine is periodic, wherein sine of x plus 2 pi is sine x for all values of x. The period is the length of the smallest interval that covers entirely one copy of repeating graph called a cycle. You can see in here, in this graph, that for sine x, one period is from 0 up to 2 pi. And some of the other properties of sine is that sine is an odd function. That is, the sine of negative x is equal to negative sine x for every x. For example, sine of negative 90 degrees is the same as negative sine of 90 degrees, which is equal to negative 1. Therefore, if this is true, this graph is symmetric with respect to the origin. So let's look at the behavior of the graph as b changes. So the b, as I have said earlier, affects the period of the curve, because period is 2 pi all over the absolute value of b. Let's focus our eyes here on the orange curve. As you can see in here, for y is equal to sine x, the period is from 0 up to 2 pi. That's for one cycle. However, when you focus on the blue, y equals sine of 2x, it means in the original period of 0 to 2 pi, you can fit in 2 cycles or 2 periods. Whereas here, for the green, sine of x over 2, only one half of the period fits in the original cycle. So let us try. For the given y equals negative 3 halves sine of 2x, let's write first all the givens. For A, that's negative 3 halves. For B, that's 2. C is 0, and D is 0. So what are the important parts? First is the amplitude. So you can say that the amplitude is the absolute value of negative 3 halves, or simply 3 halves. That means from the midline to the highest, it would only be 3 halves. From the midline to the lowest, it would only be 3 halves because there is no vertical shifting. Let's go to the period. P is 2 pi all over the absolute value of B. So that means period is pi. Now it's important to know what we will be graphing in here. So what I usually do is I divide the period into 4 parts. So now let's go to the intervals, or some people call it increments. So let's write it. Intervals or increments. I divide the period by 4. So that means the interval is every pi over 4. So let's complete the table. This would be for the x values and this is for the y values. I'll start with 0 because there's no c, there's no shifting. And then the increment or the interval is every pi over 4. So this is pi over 4 plus another pi over 4 is pi over 2 plus another pi over 4 is 3 pi over 4. And lastly, plus another pi over 4 is pi. So you can see in here that one period is from 0 up to pi. And then let's plug in the values of these x's to the original function. 0 times 2 would be 0. Sine of 0 is 0. Pi over 4 is 45 times 2 is 90. Sine of 90 is positive 1 times negative 3 halves would be negative 3 halves. 90 times 2 is 180. Sine of 180 is 0. So this becomes 0. 3 pi over 4 times 2 is 3 pi over 2, or 270. Sine of 270 is negative 1 times negative 3 halves would be positive 3 halves. And lastly, pi, 2 times pi, that's 360. Sine of 360 is 0. So if you were to graph this, let's create the graph. So let's just say this is 0, this is pi over 4, this is pi over 2, this is 3 pi over 2, this is 2 pi. Let's table. Pi over 4, pi over 2, 3 pi over 4, and then this is pi. So let's just say these are 0.5, 0.5, 0.5. So start is at 0, would be here. Next is negative 3 halves, negative 1.5, so negative 1.5 is here. So negative 0.5, negative 1, negative 1.5 would be here. And then next is at pi over 2, it's 0. And then at 3 pi over 4, it's positive 1.5. And then next is at 0. So the graph of sine would be from here, going here, going down. So let us summarize the parts. So I can say here that for the sine, what's my amplitude? It's 3 halves. Do I have any phase shifting? Phase shifting, there's none. Do I have any vertical shifting? There's none because D is 0. What is the equation of the midline? The midline equation would be y equals D, or y equals 0, because here, you focus here at y equals 0, that's the middle of the two amplitudes. And then if I ask you the period equal to pi, and then one cycle would be from 0 up to pi. But if I ask you for the domain and the range, The domain, of course, would be all real numbers. So from negative infinity to positive infinity. The range, the lowest and the highest. The lowest would be from negative 3 halves. The highest would be positive 3 halves. Okay? So let's go to the next. In here, let's write the given first. Your A would be equal to 2. It's not factored out, so maybe we can factor this out first. Y is 2 sine of 2 quantity x minus pi over 2 plus 1. So again, some of the standard forms in some books would be the one on top, and then some might be the one at the bottom. For me, I'm using the one at the bottom. So for me, the B is equal to 2. The C would be pi over 2, and then the D would be 1. So that means all the letters here are complete. I'll write what I need. Amplitude is basically 2. The period is 2 pi over B. So it's also pi, similar to the other one. And then, now, do I have a phase shift? Yes, the phase shift is pi over 2 to the right because it is positive. The vertical shift, that's 1 unit, and then since it's positive, it's going up. The equation of the midline is y equals 1. I'll explain this to you later on. As I've said, let's go to the increments. For the increments or the intervals, what I do is I divide the period by 4. So what I'll do here, the period is pi over 4. So that would be the period. And then for my x and y, I'd first look at where I would start. Since there is a phase shift of pi over 2, instead of originally starting with 0, I will be starting with pi over 2. And then my increment would still be for every pi over 4. So let's complete. 1/2 plus 1/4 is 3 pi over 4. Plus 1/4 is 1. So this is pi. Plus 1/4, that's 5 pi over 4. Plus 1/4, that's 3 pi over 2. So you can see in here that if we look at the leftmost and the rightmost in the interval, 3 pi over 2 minus pi over 2 is simply pi, which is actually our period. So let's plug in. We plug the values to the ones I have rewritten. Pi over 2 minus pi over 2 is 0. So sine of 0 is 0. But then there's plus 1. So that means this one would be 1. 3 pi over 4 minus pi over 2 times 2, that's pi over 2. Sine of 90 is 1 times 2 is 2 plus 1. The value would be 3. And then this one is pi minus pi over 2 is pi over 2 times 2. It's pi. Sine would be 0 plus 1 is 1. And then 5 pi over 4 minus pi over 2 times 2, that's 3 pi over 2. Negative 1 times 2 is negative 2, plus 1 is negative 1. And lastly, 3 pi over 2 minus pi over 2 times 2 is 2 pi. That means this one has to be 1. So you can see in here that instead of starting with 0, we will start with pi over 2. So let's count. If this is pi over 4, this would be pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. So we will start with pi over 2. This is pi. This is 3 pi over 2. Let's plot the points. 1, 2, 3. 1, 2, and 3. So at pi over 2, that's 1. At 3 pi over 4, that's 3 in here. And then at pi, that's 1. At 5 pi over 4, that's negative 1. And then at 3 pi over 2, that's also 1. So that means your graph would look like this, only one period. So if I ask you, for one cycle, it would be from pi over 2 up to 3 pi over 2, because that's also the ones in the table. But of course, what would be the domain? The domain, it could extend to the left and to the right. The domain is any real number. What about the range? The range should be the lowest, which is negative 1, up to the highest is 3. So from negative 1 up to 3. And then you can see here the midline y equals 1 in here. That's the middle midline. Y equals 1. Middle of the highest and the lowest value. Now let's go to the graph of cosine. Similar to the sine, I have drawn here the values at pi over 6. That's square root of 3 over 2. At pi over 4, that's square root of 2 over 2. At pi over 3, that's 1 half. And then 0 at pi over 2, and so on. You can see here that these are second quadrant angles. Cosine would be negative. Third quadrant angles, cosine is negative. Here, going to the fourth quadrant angles, cosine is positive. Hence, the graph is found on top. Okay, so one of the properties of cosine is that cosine is an even function. That is, the cosine of a negative angle is the cosine of the positive angle as well. For example, cosine of negative pi over 3 would be the same as cosine of pi over 3, which is equal to 1 half. For this, the graph is symmetric with respect to the y-axis. And you can also see in here that the period for cosine is from 0 up to pi over 2. The domain, similar to sine, it's all real numbers, and the range is from negative 1 to positive 1. So let's try some examples in here. So let's try separating them into A, B, C, D. Y is negative 4. Cosine of, let's factor out the 2. That's x plus pi over 2 plus 2. So the A, B, C, and D is negative 4. B is 2. C is negative pi over 2 because that's the opposite of this sign. And D, B2. So for the amplitude, it's the absolute value 4 or 4. And then for the period, it's 2 pi over B. So it's also pi. Do we have any phase shifting? Yes. The phase shifting is pi over 2 going to the left because it's negative. And the vertical shifting, it's 2 units up. So when we go back to the sign in here, you can see pi over 2 going to the right. So it moved by pi over 2 units going to the right, as opposed to it starting at the x equals 0 line. So again, in order to plot the points in here, we divide the period into 4. So those are what I call intervals or increments. I divide it by 4, so I divide it into 4 parts. That's pi over 4. So for my x and y, I will start with the phase shift. Since it moved to the left, it has to be negative pi over 2. And then I add pi over 4. So negative 1 half plus pi over 4 is negative pi over 4. Add another pi over 4, that's 0. Add another pi over 4, that is pi over 4. And add another pi over 4, that's pi over 2. Let us plug in the x values to the new equation. Negative 90 degrees plus 90 is 0 times 2 is 0. Cosine of 0 is 1 times 4, that's negative 4, plus 2, that's negative 2. Negative 45 plus 90 is 45 times 2 is 90. Cosine of 90 is 0 plus 2, that's 2. 0 plus 90 is 90 times 2 is 180. Cosine of 180 is negative 1 times 4 is 4 plus 2, that's positive 6. 45 plus 90 times 2, that's 270. Cosine of 270 is 0 plus 2 is 2. And lastly, 90 is 180 times 2 is 360. Cosine of 360 is positive 1 times 4 is negative 4 plus 2 is negative 2. So in here, let's divide them. This would be, let's call this negative pi over 4. Let's say this is negative pi over 2. Let's say this is pi over 4 and this is pi over 2. So the highest is 6, the lowest is negative 2. So this is negative 1, negative 2, 2, 3, 4, 5, 6. Alright. So let's graph. At negative pi over 2, it's negative 2. So in here, negative pi over 4, it's positive 2. And then at 0, it's 6. At pi over 4, it's 2. And then it's negative 2. So the graph would be something like this. Alright. So let's check. Pi over 2 is the last number on the right, and then the first number on the left is negative pi over 2. Pi over 2 minus negative pi over 2, that gives us pi, which is the period of one interval. So that means if I ask you one cycle, that is from negative pi over 2 up to pi over 2. But of course, if I ask you for the domain of the whole curve, it is any real number. And then for the range, the lowest that you can see is negative 2, and then the highest that you can see is positive 6. So these are the properties. Of course, the equation of the midline. Midline equation would be y equals 2. That's this portion. Let's go to the last. This one. Maybe for this one we can rearrange this so it looks better. Negative 3. Cosine of pi, this would be x plus 1 plus 2. So A, B, C, and D. A is negative 3. B is pi. C is negative 1. D is positive 2. So for these parts, let's write the amplitude is 3. The period is 2 pi over the absolute value of pi. The period is 2 units. And then the phase shift and the vertical shifting. For the phase shift, 1 unit going to the left. The vertical shift, 2 units going up. The equation of the midline, y equals 2. So in order to graph this, let's divide the period. Let's get the interval or increments. A period divided by 4 every 1/2. So you can see that instead of like pi units, what you have now are their rational numbers. So let's start with the numbers here in the table. So you can see in here that the phase shift is 1 on the left. We start with negative 1 because C starts with negative 1. And then the interval is every 1/2. So negative 1 plus 1/2 is negative 0.5. plus another 1/2, it's 0, plus another 1/2, it's 0.5. Lastly, plus another 1/2, it's 1. And then is it true that the right minus left should give us 2? Let's check. 1 minus negative 1, that's equal to 2, which is actually the period. So now let's plug in the values of x in the new equation. Negative 1 plus 1 is 0. Cosine of 0 is 1 times negative 3 is negative 3 plus 2. That's negative 1. At negative 0.5. Negative 0.5 plus 1 is 0.5. Pi, so that's 90 degrees. Cosine of 90 is 0 plus 2. That's 2. 0. So 0 plus 1 is 1 times pi. That's 180. Cosine of 180 is negative 1. Multiply to negative 3. That's positive 3. Plus 2. That's equal to 5. And then at 0.5 plus 1. That's 1.5. So that's 3 halves of pi, 270. Cosine of 270 is 0. Plus 2 is 2. Lastly, if it's 1 plus 1, that's 2 pi. Cosine of 2 pi is 1 times negative 3 is negative 3 plus 2. It's negative 1. So let's divide the Cartesian plane. So that's negative 0.5, negative 1, 0, 0.5. This is 1. And then the lowest number that you can see is negative 1. The highest is 5. So negative 1, 1, 2, 3, 4, 5. So let's plot those. At negative 1, it's minus 1. So in here, at negative 0.5, it's positive 2. At 0, it's 5. At 0.5, it's 2. And then at 1, it's negative 1. So you can see that the graph looks roughly the same as the one in the previous example. But then the units are different. So to finish this, you can see that one cycle will be from negative 1 up to positive 1 the x. However, for the domain, you know that it's from negative infinity to infinity, whereas the range, you can see that the range is from negative 1 and then the maximum is 5 units. Okay, so that's it. Thank you.